Today I would like to present the results of my work. First, I will repeat the purpose of this work and topicality. After that, I would like to present used methods and software, how the program works itself, and show the results. So, what is the purpose of this course project? The purpose of this project is to create an analytical part of sophisticated trend prediction system in Australia. The result of this project will not be a whole system for predicting rain, but rather its machine learning part. In the future, this ML part will be incorporated with an additional system that will take in consideration meteorological data from the weather forecast to create the rain and weather prediction system for Australia. About topicality. Right now, we face one of the hardest problems known to humans, global warming. With it comes a lot of derivative problems, such as floods, rising sea levels, and high temperatures. These high temperatures cause other problems, namely bushfires, and nowhere it is more relevant than in Australia. Australia is already a hot country and faces a lot of bushfires as it is. But with steadily rising temperature, these bushfires are getting way out of hand. But if we could predict those fires, we could neutralize them before they even start to cause any damage. That is where this project comes in. With it, it will be possible to determine if there is going to be rain and thus predict if there isn't going to be any. If there isn't going to be any rain in a long time, this can mean there is a higher chance of uncontrolled bushfire. This gives firefighters an early heads up, which is much needed right now. Now, let's turn back to the project itself. First, I had to process the meteorological data, which I got from Kaggle, and this data is composed of the meteorological data from Australia for every day, going back nearly 10 years. I want to use complete data for my model. That is why I look how much there is missing rows in each separate feature and drop those features where percent of missing data is higher than 15%. Yeah. So first, I would like to visualize dependencies and or correlations between features. When I do, the few that stand out have an almost linear shaped distribution. For example, max temperature and uh, day of hour of the day. It's 3 p.m. I think, and same here, also here, and quite number of others. Now I need to encode the categorical features, and I will use one-hot encoding as it is a standard method in the machine learning. So this is the result of the encodings. Okay, and now after I have my data processed, I can build my model. I will use the random forest classifier, and here is a good place to explain how the method itself works. So, random forest classifier is a meta estimator that fits a number of decision tree classifiers on various subsamples of the dataset and uses averaging to improve the predictive accuracy and control overfitting. So uh, pro for this program, I used around 200. Well, I used exactly 200 tree classifiers for this forest, and uh, with that, this concludes the model fitting. Now to evaluation. My model came up with a score of 85.92%, which is not bad, but it does not give us the whole picture as it's just a rough mean of the accurate or of the score. Accuracy score, on the other hand, is around 84.7%, which is still not great, but not that bad. Sensitivity, or as it is also called recall, clocks in at 96.57%, which is pretty good, and specificity, also known as precision, is at 85.64%. Furthermore, area under curve for our model is 0.862, which is also is not bad. So also I conducted an experiment to see the difference between precision and recall. We can clearly see it here. Uh, these values are clearly influenced by the decision threshold. So if we want a higher recall, we can shift the threshold to a higher value. Uh, but it can cost us some precision. In conclusion, here we have a random forest classifier using meteorological data from Australia for around 10 years back. The accuracy of this model is around 86%, which is not bad. The area under curve score is 0.863, which is also not that bad. We also determined via experiment that by shifting the decision boundary for the model, we can influence precision score. This technique can be used to manually set the threshold for the training classifier, for example, by an experienced meteorologist, which this system is catered to because uh, it is made to better predict weather and rainfalls in particular. And that is it. Thank you for your time.